Which brings us to linear programming. Linear programming is a way to optimize profit or margin in a refinery or any actually complex system of equations. It's a numeric method to solve and converge and optimize a linear function subject to linear constraints. And actually there are many solvers out there now that can incorporate nonlinear equations and constraints. The idea is to either maximize profit or minimize cost. And sometimes the two of them together end up being the same. But one of which is what you call your objective function. What is your objective? What are you trying to maximize? What are you trying to minimize? And then it uses a matrix of coefficients for each variable. It'll make a little more sense here in a minute when I get to the example. And then it actually comes up with a true optimization, the values given your constraints that have the high. You can be confident that there is no other value in this solution set that has a higher maximum. There may be more than one solution. There may be two sets of values that both provide the maximum, and maybe you only have one of them. But there aren't any others that have a higher product when put into the system. The way that all works is it actually, there's a feasible region, and you have all these inequalities. It can't be higher than this, and it has to be greater than this. You have this polygon, or what's called a polytope. As long as it's a convex polytope, it can solve and optimize that system of equations. So why use it? Well, nearly every refinery uses linear programming to optimize their gross margin on a daily, weekly, monthly basis. You have dozens of feedstocks and dozens of products and dozens of blends, intermediates, emissions, waste, etc., and you have different ambient conditions today versus tomorrow. How do you pick the mix? How do you say, I want these feedstocks going through these units to produce these outputs, and know that you've got the one that's going to make you the most money that day? A linear program will tell you that. It also is useful if you're trying to decide, well, what units do I want to add to my facility? Valero and others will go through a linear program to say, okay, well, this particular heavy ends will, if we upgrade or improve that will give us this margin, this return on investment. We're going to, often the decision of what to build goes through a linear program. What's out there to use? Well, AspenTech has PIMS, that's a very common one. Honeywell has RPMS. Haverly has GRTMPS. I guess you have to have an acronym to have a linear program. But one that you all have on all of your computers is actually Microsoft Excel. Microsoft Excel can solve a great deal of linear programs, not nearly as sophisticated as is needed to do a whole refinery, but you can solve some very, what would be complex systems of equations and get the optimum value. There's all sorts of opportunities to do that with Excel, and we're going to go through a quick example here. So first of all, you have to make sure solver is enabled on your computer. Then you have to identify, okay, once you've got that, what am I actually trying to solve? Begin with the end in mind. What is the right question to ask? Not what is the particular answer I'm looking for. What is the right question to ask? Am I trying to maximize profit? What am I'm trying to minimize something? What are you trying to do? And then if you put it into a structured format, it actually helps you set up the problem correctly to make sure solver is actually giving you meaningful information. And then you put all that information into the solver add-in and you say solve, and it gives you the optimum value. So for example, let's say we had multiple coffee beans. And let's say that we wanted to have a total of 1,000 pounds of beans, but we only had on hand 400 of bean 3, 600 of bean 2, and 500 of bean 1. And they had different aroma and taste ratings and different costs. We want to have the mix that meets this 75 aroma rating and an 80 cost rating, or sorry, taste rating, but has the minimum cost per pound. Basically, if you put it in this kind of format, helps make sure you're putting it in correctly, where you have your variables that you're changing across the top, and this is actually the optimum solution. Normally, you'd put in 0, 0, 0, because you don't know what the answer is going to be. But you put in any number, really, any feasible number. You can't have negative coffee beans, so you would make sure that you don't do that. And then you have, okay, for this sum product, 50 cents times that many pounds, 70 cents times that many, 45 cents, you get a sum product result here Divide by the total number of pounds, get your weighted average. This is just a text to show you what's going on behind the scenes here. This is also just text, but you're going to tell a solver that this value calculated here needs to be greater than that value there. So you can very quickly come back, well, what if my taste rating or aroma rating didn't need to be 80, it could be 78. What would my mix of beans be then? You can do some very quick sensitivity analyses with this. This is an old picture of solver. It looks very different now in 2013, but the effect is the same. You say, I want to minimize, in this case, the cost, which was this cell here, and I want to change these cells here subject to these constraints. And you go back and you say, these have to be greater than these, and these have to be less than these, and we have to have 1,000 pounds total in the end. You click solve, and it comes back and it tells you, okay, we want 500 here, 300 here, 200 here, and you're always up against one of the constraints. You're never going to have something where you had a taste rating of 76 and a taste rating of 84 and an aroma rating of 76. It's going to be against one of these constraints. Otherwise, you haven't maximized anything. That's one way to know if you're getting a real answer or not. But this is all built into Excel. You can do this afternoon if you wanted. If you have something, I need to find the optimum solution for whatever it is you're trying to do. We do this a lot with reliability values, which we'll get to next.